Hello and welcome to this session. Today we will learn about machine learning model and its deployment on localhost and Heroku. So, if in this part of the session, we will make a simple machine learning model using breast cancer data. So, this is the data dictionary. Let's get started. So, I'll just run the imports, necessary package imports like pandas, numpy, cborn, matplotlib, and sklearn's decision tree classifier. For the sake of demonstration, we are not performing any exploratory data analysis or we are not taking any hyperparameter tuning or any other algorithm. To get the data, you have to click on files, upload from here, and I have already uploaded that. And to get its path, you have to click on copy path. So I've pasted the path here, and I'll just run the file. I'll check the head, and this shows a named column, which is unwanted. We'll just drop it using drop function. Then we'll move on to check the missing values. If there is any missing value, there are 16 missing values. We will drop the missing values for this session, and we'll check the info. What type of data types are there? There are integers and float data, and one object, that is the target variable class. Class is our target variable that we are going to predict. So we'll see the summary statistics. So there are 683 number of rows left after dropping the missing values, and these are the summary statistics. So let's move on to uh, dividing the data into dependent and independent variables, as y being the dependent variable and x being the independent variables. Using ilog function, I'm just removing the last column and keeping all others. The last column by default in this data set is class, which is our target variable. So I'll just run this code, and in this I'm gonna use sklearn's model selection to split the data into test and train, and I'm gonna take 10% of the train set as test set. So my test set will be 10% of the training data. So that's why test size is 0.10. I'm taking random set at 1 2 3. So I'll just run this code. So I'll instantiate decision tree classifier with random state 1 to 3 and max depth as 7. This can be taken lower or the higher, you need not provide it. So I'm just taking it 7. So I'll just fit the and it will show default parameters that were taken uh, during the fitting. And I'll just print the accuracy score for train set, which is 99%, and accuracy score on test set. For classification problem, it by default calculates accuracy using dot score. If it is a regression problem, it will by default get you R squared. So let's check this metrics, other metrics, let's say confusion metrics. So to do that, I will import metrics from sklearn. From sklearn import metrics. Then I will plot the confusion metrics by providing the instance of the model, the test set, and the dependent variable of the test set. So uh, this is how it looks. Now, for the other parts of the session, we will dump our model's intelligence into a binary file using pickle library. So we will import pickle. This is the spelling of the pickle, and how do we do that? So first I will name a file name. You can directly give the file name here also. So I've done like this, ttc.pkl and pickle. I imported the pickle.dump DTC, the instance of the model, open file, create a file, and write in binary. It will dump the model. So by default, the file will be here since this is Google Colab. So what you can do is you can download this. Click here and download the file. So to check whether it works properly, I have loaded it using pickle.load. Open the file using the path. I can copy the path from here and paste it here and read binary. I'll just run it and check if my scores are coming fine. So I'm getting the test scores. So the model has been saved. So in the next lecture, we will learn to deploy this model on localhost where you can input any data and your model will predict whether the person has cancer or not, whether it is benign or malignant. So what is benign and malignant? So these are the classes that are predicted. Benign and malignant. These are the classes. So let's see. So see you in the next lecture. Thank you.